Thank you, everyone, for joining us at the AI seminar today. My name is Gail Pally. I'm President of Technology Alberta, and we're very pleased to partner with Amy and the U of A AI seminar. I'm bringing Alberta companies that are using AI and ML in their products and innovating locally and globally. So with that, very excited to have Trust Science here today, represented by Lenora Thomas and Matt Lavoie. And Lenora is a community builder across the province, a huge champion of Alberta technology. And so it's been my pleasure to get to know her over the last 4 years or so. And before I turn it over to Trust Science, I'd like to thank Justin Stevens, who's the lead volunteer with me on our relationship with the AI seminar, where Justin is a master's student and passionate about AI, ML, and the companies in the ecosystem that use that technology. So with that, I will turn it over to you, Lenora, for more introductions to yourself and Trust Science, and please take it from there.
Certainly. Thanks for having us today. So my name is Lenora Thomas, and I'm the VP of Customer Operations at Trust Science. So I help our clients actually use AI and ML in their day-to-day world and make their lives a little bit easier. And I'm joined here today by Matt Lavoie, who is our VP of Data Engineering. And he's actually the person that you guys are going to want to hear talk today, because he is the person building our models and doing all of the work. So I'm going to let him introduce himself and give you a brief intro. And you're on mute, Matt.
Always good start. So I run the data engineering analytics at Trust Science. So my team is the one responsible for dealing with the data sources that we want to integrate with and what's coming in, working with the models, building those, and then make sure that once something's actually deployed, we can actually monitor and keep track and revise and continue that process. So I graduated from the U of A. Russ was probably one of my first teachers who taught me AI. That was one of his course, and have been in Edmonton since, doing a bunch of work with a bunch of different companies in this field.
Excellent. So we're going to get started. One of the things is the floor is open to ask questions, so feel free to unmute yourself and ask them or put them into the chat. We're good with either. And let's get started. All right. So we're going to start with what Trust Science is doing. So for Trust Science, the problem that we're working with is that over 30% of Canadians and Americans have credit files that are either thin files, little data is available on them, or no credit files. That means that they actually don't have a credit score or credit file available to them. This equates to about 60 million people that have issue getting credit from banks, and they are considered subprime borrowers. So the only way that they can get money is to actually go to alternative lenders. The reason being, credit files are built on previous credit data. You have to have had a mortgage, a student loan, credit cards, car loans. And if you've had none of these, you don't have a credit score or credit report, and we're trying to fill that gap. So our solution is that we use machine learning and we gather data from alternative data sources and combine it with credit bureau data to create scores that correlate to the probability of default for subprime borrowers. We build standard industry models broken down by country, as well as custom models for clients and test models for new market segments. So not only do we work with payday lenders or installment lenders, we also are checking out credit card and mortgage data. And our goal is to allow lenders to better identify who they can lend to with less risk. One of the things that is interesting is, for instance, in the southern US, their default levels are about 40 to 50% on the loans for subprime borrowers. So we're helping them take that down and be a little less risky. So why are we disrupting traditional credit bureau scores in the subprime market? Well, The first reason is that 1 in 5 people have an error of some kind on their bureau. So that can be address issues, that can be employment issues, and that can be actual data due to fraud. So they've had fraudulent hits against their accounts, and that can lower their scores and put them into the subprime market. There's thin file and no file borrowers. So an example that I have on the screen here is that 15% of Black and Hispanic Americans don't actually have a credit score compared to 9% of white and Asian Americans. And 45% of adults in low-income neighborhoods are credit invisible, so that they don't have scores, or thin file. And the other part of this is that because the traditional bureaus only use traditional data like that mortgage and car loans, 30% of Canadians and Americans just don't have that on their file, so they can't actually rank order those applicants. So they just can't provide a score that gives you any real understanding of who those people are and how they would be able to pay back a loan. And that's where we come in. We are able to rank order those clients and score them. So just for a bit of background on how traditional credit scores work, credit bureaus and lenders take a number of factors into consideration, but they're all, again, based on basic credit data. So they look at your payment history. Do you make all your payments on time, all of the time? Credit utilization, how much credit do you have available to you and how much have you used? So if you have $10,000 that's available to you and you've used all of it, that's usually a bit of a problem. The length of your credit history. So if you are just graduating from university, chances are that you have a lower credit score than your parents do. This is something that is actually a huge impact for people that are moving between countries. So if you move from Canada to the US, you actually start off at ground zero again. You have no credit history in the US and your Canadian history doesn't carry over. As well, if you're new to Canada, so you come here for school, you don't have a credit history and that has a negative impact on your score. It also looks at new credit inquiries. So the number of times an inquiry has been put against your credit score. So example would be if you apply for a new credit card, that's going to be a hard pull against your credit score. Another example that we see some of our borrowers do is they are getting an auto loan application. They decide to go into 4 different dealers on a day and each one pulls a credit inquiry for them. By the end of the day, their credit score will actually be lower, which isn't as much of a problem using our score. And then credit variety, again, lenders want to see that you have a personal loan, a credit card, a line of credit, and that you're in good standing for each of them. And so this is how a traditional score comes together. They take each of these and that data is used to build your credit score. So this is where the big difference comes in for us. We use the traditional data, so that traditional credit data, as well as alternative data to build our models. So we have access to a lot more information on these individuals in terms of their behavior and how they're spending their money. We use data sources that include the credit reports. We use banking and public data. And we use actually the same score range that a traditional score would provide, so that 350 to 850. So that allows us to look at the risk of default. So we can say that a specific score aligns with a specific risk of default. And then we can work with our clients on the specific business objectives. So are they looking to decrease defaults? So if they are at 40% default, do they move to 30% or 35%? Or are they actually looking to improve the number of people they're giving loans to? So, they're at 1,000 loans a month, they want to go to 1,500 loans a month. We can help them with that. So one of the big things that we deal with is data. And so Matt's going to dig more into some of the challenges on that a little bit later in the presentation. But we wanted to give you an idea of the type of data that we work with. So outside of that bureau data, that credit data, we look at banking data. So that can include your raw transactions for the last year, looking at actually where you spend your money and how you spend your money, what sort of payroll you get. All of that is really great data for us to use in modeling. We look at identity data. So who you are, where you live, what your identity is, if there's any fraud that's going on there, that's all information that we can use in our solution. it can be very important. For instance, if your credit bureau or your public data says that you're debt, chances are you don't want to lend to that person. We deal with loan application data, so that's your standard information, like, do you own or rent? Do you have a job? How long have you been in that job? And that ties into the employer and job data. So what type of industry do you work in? What sort of role do you have? And then we look at public data and market data. And this is a bit more interesting in, I would say, in the US than in Canada. We have different sources available there. But public data can include everything from evictions and court judgments to criminal behavior. So have you been involved in a felony? Was your last address actually at a correctional institute? This is all information that we can have access to in the States, and unfortunately isn't available in Canada, which makes us a little sad sometimes, although we don't necessarily want to know that people went to jail. But that's all data that we have availability and that we can put into our models. Matt, anything you want to add on there?
That's good.
All right, so one part of that data set that you heard me talk about was banking data. And this is a really important consideration for us. With banking data, it's not like we can just go out and get that data. It actually has to be consented data. So applicants actually have to provide us with access to their data. So the example that we use most often is banking data. So if we were to access banking data, if you are an applicant for a loan, you actually have to log into your bank account and provide us with that access. We can also do that in other data types, so utility data, so that we can see your utility usage and payment history. We can look at social data, so Facebook and Twitter, Snapchat if we wanted, to see personal information that they choose to share with us, as well as employment and payroll data. So depending on who pays you, we can actually get access to all of your payroll history. So a lot of great deep data available to us for modeling purposes.
Lenora, I have a question here.
Sure.
So what about data privacy? So if someone is, let's say, has a energy company, they're their customers, why would energy company will share that data with you?
It's actually the applicant's choice to share that data. So they are actually providing us with consented access to that data. So it's a choice on their behalf. And so there's not that privacy issue there. They're making it available to us.
Okay.
Yeah.
Wonderful. Thanks.
Yeah, and so just to give you an idea, so a traditional bureau score, again, we mentioned it goes from 300 to 850, and they're segmented. So anything below 670 is considered bad or poor and is a subprime borrower. So that's the group of applicants that we're working with. And what our goal is to do is we take the bad and the poor and we spread them out across the entire credit spectrum. So we can find people that are the prime in the subprimes, and we can provide a better rank order and probability of default because we're looking at different data sets. And so from there, the type of loans that we work with, we work in both Canada and the US, and so we have to build models that are specific to those different segments. So we work with auto loans. These are loans that average 72 to 84 months, and they're up to $30,000. Average is usually in the 20 to 22,000 range. We work with installment loans, so completely separate models in both Canada and the US, and very different from auto loans if you look at the dollar figures. So we're looking at $500 to $10,000 as a general rule for an installment personal loan. And they can range anywhere from 6 months to 5 years. Most of them are less than that. And then we work with clients that are dealing with payday loans, and payday loans are generally paid your next payday. So those are usually $50 to $2,500. So for each of these, we have to have very specific loan models to be able to properly understand what sort of risk they are to default. Which moves us into the model purpose. So we have different types of models that we work with. So beyond industry specific, the auto, payday, and installment, we have different types of models. So the main one that we work with is the probability of default. So again, this is how likely an applicant is to default on their loan. But we also offer marketing models. So using a probability of default and a propensity to respond, we can actually help our clients market specifically to the people that they are looking to give loans to. So they can say, hey, you've been approved for $500 if you come into our store, and that person is already pre-approved. It helps them just make sure that they're actually getting the word out to the right people. And then we do recommended loan amount models. So beyond saying, hey, this person is going to be defaulting at this level, we can actually say, you know, you should only give them up to $500. You shouldn't give them $800. We can actually recommend how much the loan is so that they don't have to do as much work. And the next slide, I am 100% handing over to Matt. He'll be able to better describe them.
Yeah, so to do everything that we've talked about so far, there's, I guess, 3 different types of models that we use a lot. Our typical PD models, the probability of default, those are typically binary classification problems that we work with. We also build like propensity models for marketing purposes. There's multi-classification as well when we're looking at banking, and that's trying to classify banking transactions. So we try to identify, you know, is this an income that a person's receiving? Is it a loan, something different? And I put pseudo NLP because in banking, there's so much jargon in there that there ends up with very little actual text. Almost everything in our banking transactions, when you look at it, is either truncated or comes from some other abbreviation, something within the banks. And so trying to use like pre-trained language models and other things, they help a little, but not as much as you would think. And then we have our survival models where she was mentioning like recommended loan amount. It's looking, okay, yeah, what amounts can a person handle and support? And again, you see situations where somebody might be a great borrower, but only up to certain amounts. And then you'll like see the, you know, their debt to income ratios and certain things, and they'll not be able to pay back. You can move on to the next slide.
So one of the things we thought would be helpful would be to actually provide you with an example of how we worked with a client. So we had a client come to us and they provide installment loans. And they already had an internal model based on traditional bureau data, but they were looking to see what the impact of alternative data would have on their process by overlaying us with their internal model. So the goal was to rank order their applicants better using that alternative data on top of their existing process, and improve loan decisioning by predicting which borrowers would default or go 30 days delinquent within the first 12 months. So we approached this by bringing in specific data sets. So we brought in banking data, so the raw banking transactions, incorporating banking attributes that look at bank balances, non-sufficient funds, and spending habits. We looked at traditional bureau data, so the credit usage. We looked at social data, so data sources like LinkedIn, Facebook, and Twitter. You'd be amazed, it does make a difference. And loan application data, so phone, address, employment information. And the outcome of this is that we were able to give return on investment of 10 times over it. And we had a charge-off reduction that moved them from 30% to 22%. And I'm going to say we had a 65 AUC ROC, so area under the curve. But Matt, did you want to add some specific details into that?
No, that's fine. Just a good metric for comparing the rank ordering of the scores.
Yeah, and so on the left-hand side, you can see the population percentage versus the buckets that we put the clients in, and the bad loan rate. So we were able to provide that information to them to help them better their business. And so I hand this over to Matt again, because he's going to actually speak to the challenges.
So I guess one thing to highlight is that instead of just thinking about credit scores as a single score for a person and it's applicable across all different areas, we do build a lot of different scores. We'll build a different score for like an auto industry versus what you might get for an installment loan versus what you might get on a payday or some other loan type. So we end up developing a lot of different custom models as well that are focused on, maybe geographies, certain other characteristics. And we try to combine data where possible, but also realizing that trying to create something generic will not be as useful for the customer. So we've really structured our data and tried to bring in other data sources to standardize that. So just doing that at scale, being able to develop a model quickly, but also being able to then deploy it out and have all the checks and balances along the way done. That's in itself is probably one of the bigger challenges. So I guess the scores that we have as well is not always the same as what you would use to make a decision. So we have to also, think about it from a business perspective. I can generate a score and that will tell you the risk on someone. But when it comes down to it, they might be in a very competitive space. And even in the auto loan industry, it's almost set up like an auction system through systems like DealerTrack. So it'll be sent out to, a dozen different lenders who will all be betting on the same loan. So, you might say, hey, this person is this good or this bad, but they might not have that much flexibility moving around because they might not get the loan to begin with. So the person may not take them up on the offer. So that's a challenging piece whenever you're bringing forward any scores. How do you actually use it? We've got reject inference as a problem. We're looking at a certain amount of data. Well, what about the people who never got loans? How would they perform? You don't know on the unknown population. That's what reject inference is. Thin files are, we can rank order them, but they're not going to have the same level of certainty as some of the other ones. They might still rank order in the grand scheme of numbers, but the range and, customers will have different risk appetites on what they're willing to do with that. And those situations might change very quickly depending on the landscape. And this is where COVID and other things like that came into play. Government funding turned out to be great for lenders in that short term. In subprime, a lot of people who didn't have the money now had extra funds from the government and were able to pay them off. Well, that's no longer the case. So, how are these models reacting after the fact and everything else? Really important. So we talked about the ROC. In subprime, it's actually really difficult to get high performing models. We're looking at, a lot of things that are behavioral when it comes down to it. Data is very noisy. You might get only a few evidence points in someone's credit file. Like we said, thin files, these people are not getting a huge amount of loans. And typically in subprime, everyone has defaulted on at least one loan in the past. So they might not have a whole lot of recent data. So how can you tell that person's good or not? It's very difficult to do that. We've seen evidence where, we're using binary classifiers, but I have seen banking data from the future of a person who reapplied for a loan and realized that on previous loans that they had, it became a luck of the draw. Who got, sorry? Yeah, I was just saying that it became some of a luck of the draw on which person, which of the lenders ended up getting the money. So they could have like two different loans, but on the day they only have the money to pay one of them. And it's literally whichever one the bank ended up processing first got the money and the second one didn't. So to one lender, that person looks great. To the other one, that person looks like they defaulted and is not paying back the loan. So these kinds of things are happening in this area. Fraud, very prevalent, ongoing, and interest rates are also really interesting because if you have too high of an interest rate, you might have someone who defaults based on that because the payments become too large versus if they had received a lower interest rate, they might not have defaulted. So you could have somebody that would be a great borrower just under the right terms. And we'll also notice that in the prime space, there's a lot more separation between individuals than in the subprime space. I think it's more predictive. So the way that our company is set up, we have three different groups. We have our applications team, which is, they deal with the front end. So connecting to the APIs and allowing us to do live scoring with different loan management systems and other things. We have the data warehouse, which is really just the group responsible for storing and for managing and organizing all of that data, and keeping that up to date and refreshing it for us. And then we have my team, the data engineering analytics, where we do the data science work is where that comes in. But we also do data sourcing, so we're looking and expanding and looking at different sources. Yeah, so I kept some of these slides from a previous one we did with students, but you know, in our team, you know, people think that you spend a lot of time just doing modeling, but there is so much time that you have to always spend doing that ETL work, transforming the data, cleaning the data, validating it. We run into situations where the data that you're going to get in production might be different than what somebody gave you historically, and being able to catch those differences really early on are key to being able to do this efficiently and quickly. There's a lot of, so that handles the monitoring, our analysis that we do on this data as it comes in, and building systems to do that very well. And then building this pipeline so that when a request comes in, we can pull data sources from, we can pull all the different data sources that we get data from, and we can generate that score in a reasonable time frame. Because in some of our cases, we're dealing with very time sensitive decisions where a customer could literally be on a screen waiting to know if they're accepted before being asked to do the next step. So even on my group, we have a lot of different types of engineers. This really, I guess, from a data science really covers a lot of the different areas, but we have each of these in our company. We have, our data engineers, data scientists, software engineers. We have to have people who do the governance to make sure that, we're in a very regulated industry. So it's very important that somebody's aware of what those are and that these models will comply. That we're not violating, that we're using things that discriminate against certain individuals. And those, even different states will have different rules. So we have to keep that in mind all the time. And then the analysts that we have who are putting together the actual strategies. How did we use this score and actually do something with it? And if we generate a model, what we see that's performing well now, and that's the best performing based on the data we have, isn't always going to be optimal. And there's obviously many reasons for that. I mentioned before the space is very competitive. One of the biggest challenges is often that we can only measure performance sometimes many months or even years after that loan was given. If you have a car loan, it lasts a very long time. And so you may not find out in the first 6 months if someone is good enough to do most of the repayments. It may only happen later. And so you may have built a model that inherently, depending on what you used in your model, might work really well for much shorter terms decisioning than longer term. And again, the strategy of how you're actually applying this thing really matters in the end for what's going to be optimal for that customer. Yes. So I think we had that one last time, Lenora, just about some postings. I think, I've already gotten, I think these are already up. And so we've already gotten some students applying, but we are always looking for, new individuals. So it says student postings, but we do have postings in a lot of different areas right now in trust science. So there's quite a few different engineering positions open, front end and back end, and on the data side. So we're always open for
Apply now, apply often. Could you give some high-level information on how many people work for trust science currently or over the years?
We currently have a team of about 45.
That's a big team. You have a lot of scientists. That's awesome.
Well, the data science side, that's our entire company. The data science and engineering side is, I think we're in 20 for that. 20, 25.
We're above 20. We're getting
Yeah.
closer to 25 for sure.
Yeah.
Yeah, somewhere around there.
That's exciting. And I've never seen such a great understanding of 5 different positions within a data science or analytics or machine learning group. So that's exciting.
Yeah, we actually have, and I see that separation every day with the different people I work with, right? Different roles that people have to do.
That's exciting. Awesome. If you could stop the sharing of the screen, that would be great. I know we have some questions in the chat. And also happy to have Russ and Justin joining us. Justin, where do you want to start?
Yeah, there's a few questions on the chat. Maybe were those already addressed or not? I saw some of them were.
There was a question about the origin story of Trust Science and or its founders. We didn't answer that one. And the second one was, how do you update the feedback in terms of who are good loan risks and how they have performed? So I'll take the first one if you take the second one, Matt.
Okay.
So origin story, our founder, Evan Krapko, is a longtime tech entrepreneur. So his first business he started before the tech boom and bust of the early 2000s. And his first business was a company called DocSpace, and it did document management, which he sold for $528 million back in like the year 2000, which is really amazing. So he and his team did that. He's been involved in the community since with a number of different projects, but this is his latest one. And the first time he actually started thinking about it was back in 2006, 2007, where he was wondering how you could, from a computer and machine learning standpoint, identify who you could trust. He was looking at how you could do that. And his original idea was to start this on a very broad basis. Like, you know, it could be used for insurance, it could be used for dating. But back in 2006, 2007, machine learning wasn't quite in the same place that it is now. So it took a little while for him to get the team together and to get started on it. And so when they first started looking at it, it was decided actually with Chris Matichuk, who's the brother to Bruce Matichuk, who's on the call here, I believe. He came on board and helped us really define working in credit scores. So it's been a bit of a long road, but we've got a really great path that we're on right now.
That's really exciting. I know that Matt will answer the other question, but to that interesting point, it's important to focus. So you have an outstanding focus, especially as it can help people that are newcomers and new to the loan environment, right? So many people get in on these high-end loans because they can't get any other way. I would think that, you know, the payday loans, they get the people who don't have a lot of options. I think you give more options, more of the traditional owners will take on some of these others. And so it may take away some business from the payday loans, which is okay by me. But, you know, I do see that they're a customer too. So I see that there perhaps is some give and take from the payday loans kind of customer. Is that true, Lenora?
And there is. The unfortunate fact is that, though, that once people become part of payday and installment loans, they tend not to grow into other options. They get comfortable and they stay there. The goal for a lot of organizations is to actually help people grow their credit portfolio. But it all comes down to education and opportunity, and sometimes that's just not how it works out for them.
All right, I see an important cause here. and there is an accelerator, you know, Lenora, I know you know a lot about what's happening in the tech space, and that there's the Community and Safety and Social Wellness Accelerator. I think to help people, that would be very cool. obviously your company is way beyond an accelerator, but it could be, I can see spin-off companies here. All right, sorry about that. Matt, over to you.
Right. So I think that the question was about how do we update the feedback for the risk and determine who's performed on. So that's a complex problem in itself, and we have to deal with all the lenders that we deal with. Part of us offering a score is also that they provide us with their performance, and I wish that was more standardized. The bigger companies that you go to, the more they have the tools in place to report to the regular credit bureaus. So, every credit bureau has this general format that they've taken in for many years, and all the credit bureaus support it. And we can obviously support that as well. When you're dealing with the smaller groups, they don't often have that. So it's part of us taking that in and doing some work to massage that into something that then can fit into our structure as well. Whether that's a payment schedule that a person followed, or something just even more basic as far as just, each month, are they still good or not? Just even that would be is a good start. So
I could see you're taking large amounts of data. So to find out that if your prediction on someone's a good credit risk or not, it's hard to get the individual feedback back when you have probably more large audience feedback or demographic.
Yeah, we do. Okay, right. So somebody asked the question about explainability. It's Bruce, brother to our CTO. But hi, Bruce. So yes, I on our end, we do a lot of work on trying to figure out how do we provide a score, but also how do we explain what it is a person has to do. Especially in the US, there's a lot of regulations about providing people feedback so that they can actually improve their score. So that's always a goal, that every person who gets a score will also get some feedback to say, hey, look, these are the key elements of what you need to do. Too many inquiries is a common one that would come up. But now that we're pulling in banking or certain things, we can look at the actual ratios that a person might have, and those things will come up as well and say, hey, look, you're over leveraging yourself in certain, not those specific words, but essentially all the attributes and the way that we report back can do that. We've done a lot on explainability in a few different, we use a few different main technologies. They're all published. SHAP is a big one. Shapley values is key. We use a lot of, and even within that space, we've worked with like Lime and some other things as well to try to narrow that down. But I think it's also to interpret that, how you group that and how you represent that after it's gone through is just as important. So then other questions about NLP. Yeah, so we have some things in our system, like when we do the categorization of banking, that is one area where NLP essentially comes in. We're trying to figure out what is this loan based on the small description, or so what is the transaction based on the small description that you see in your banking. And you can see when you look at those, there's a lot of codes that show up in there. Some are meaningful, some are absolutely meaningless. They're based on the merchant code, they're randomly generated. We have used some more generic language systems, like I mentioned BART before, and GPT. BART, I know has been useful in that case. GPT stuff was less so, but it's always worth revisiting all the time. And I think this is partially a problem that it's an evolving space, and different people are moving into, starting to utilize that data a lot more. Open banking is becoming more important. So I'm seeing a transition where now the text is actually changing over time. People are not used to the same short descriptions. And so if you look at banking from X years ago to now, things are actually transitioning over time. So I'm actually hoping that more and more we're going to see better use for that.
I see a question in the chat asking about who your competitors are. And there's a point that Credit Karma is an American company that is helping to educate people about their credit score.
Yeah, so Credit Karma isn't quite a competitor. They provide people with access to their credit scores, and they actually act as a lead generator for lenders. Primary competitors would definitely be the traditional credit bureaus, so TransUnion, Equifax, and Experian in the US. And then there are other companies that are building custom models based on a specific data set. So a number of options out there.
Trust Science has been around for 5 years or more. So I'd say you're your leading company in using AI for this purpose, right?
Definitely.
Very cool. Bruce, did you want to ask your question?
Well, I posted it. Another question, yet another question. So you have these really complicated models, like, and there's all different things that you're trying to model. I guess you're trying to integrate it all into one coherent model. So really the question is, like, how do you put that all into one coherent model so that, you know, data coming from one part of your model is actually relating to data in another model? Because, you know, ultimately I'm assuming that you boil it down to a set of features, and then you have some kind of a neural net or something that you pull out some kind of vector, and then that vector represents the decision that you make. I mean, I'm imagining that's what you're.
That's right.
Maybe it's proprietary, but you didn't give us a nice architectural diagram. That would have been helpful.
Yeah.
For AI guys. But anyways, how do you integrate it all together?
So that, yes, and that's it, because there is a lot of proprietary stuff that we do in there. But on maybe at a higher level, what we tried to build, okay, one model, it tries to have one purpose, is really one of the things that we try to focus on. So if I'm building a probability default, that would be definitely different than a recommended loan amount. And those two, somebody would have to look at both of those and build a strategy that combines both. We're not going to optimize it for the customer. We're really trying to build something more generic as a product that then I can take that score that works well in auto and enhance it, maybe combine all our auto data and build a more generic Canada auto model, we'll say, right? That incorporates a lot of different data from a lot of different groups. As far as how you engineer your features from the very beginning is very key in that process. It'll be key in how you, the representation of the data. We've gone through multiple iterations trying out different ways to transform it. We've tried, there are some always handcrafted ones. We've tried some more machine generated features. And it's important for us to always know how we can group that so that explainability is not lost in the process. And so that's always something in the back of our minds whenever we're generating something. We have to make sure that works. In the end, what we do for the testing of the model and how we can validate it, and we have to validate it in different spaces to see that it's behaving as it would, right? We're doing a lot of analysis. There's a lot of data that's, we often have our training data, but we also have holdout data. And that holdout data sometimes even in the future, we want to make sure that our models are not just focusing necessarily on just the short term, but that they're going to work long term. So actually, sometimes we don't even include data from the most recent in order to see what best optimizes on that. And then we're trying different strategies to basically make that work. So there's a lot of data that is held out, that is used. There's a lot of test data. There's a lot of different things that we try in our first round. So that we can actually, make a model that is perhaps less complicated. Like, well, how can we reduce the features even, right? If you can do that and still keep the performance relatively similar or on par, that's always seems to be a win overall. Helps a lot of different levels.
Do you do principal component analysis to try to figure out which features are relevant?
Yes, and in some cases, we even have used it in doing reductions within sub portions of our system as well, and have had varying success with that, we'll say.
Very interesting. I was involved in the company called Matricon, as well as various advanced control companies where we have tuning parameters for each of these elements, and including principal component analysis. So it's a really good point, Bruce. And I could, so that's the secret sauce, could be what these tuning parameters are, as well as I could also see a case for sociologists and psychologists to be a part of your team now or in the future, because there are like global impact problems or conditions that cause people to behave differently. So this is so cool. It's almost like a combination of your work with SamDesk that has a little bit of, although SamDesk is more emergency response, but there's some interesting things going on. I have an interesting question in the chat from Daryl talking about attracting and retaining skilled and experienced tech workers. So definitely something near to all of our hearts. Lenora, is that one that you want to cover?
Sure. Although from a tech standpoint, I don't hire as many of the tech side of things, so Matt might be better to do that. We've been lucky in the team that we've brought on board to this stage. One of the great things about working in machine learning and artificial intelligence is that we have a really interesting problem, and it can be complicated, and it can be challenging, and people are interested in that. So that does help us definitely on the hiring side of things. What other factors other than
I think,
yeah,
when I think about, like, I think in this situation, we're much more remote now, and I think many companies have sort of switched that out of necessity, I guess, in many cases, but that sort of helped us, and I think we've branched out and have started I think we have actually quite a large group of engineers from Toronto, whereas I would say before COVID, I don't think we had any. But now we have a good handful. I can't even count how many we have. So we're in the situation where the pool of people we have access to has expanded, right? Where it makes it easier to bring people in who can work from anywhere. And yeah, makes it, like she said, I think there's a lot of attractive things about this company. So
outstanding. So because you have challenging work and you are flexible as far as working remotely, that helps you attract and retain employees. Anything else that's exciting, makes it exciting to work for Trust Science?
the people are great.
The people are great, of course. That's awesome. It makes all the difference in the world.
Yeah, I think we have a good company culture. I think that's a big piece, right? So that's still there's a lot of the, I'm going to say a Canadian influence still that you can actually feel and notice there in our company. So that's good.
Excellent. Could you describe the corporate culture?
Lenora's actually helped on that front more than, but that's what terms would I use to describe it?
We're a bunch of geeks that really like to, we play board games and Kahoots, and we were having a conversation about which was better, Star Wars or Star Trek this week. But
may the 4th be with you, right?
Yeah. Even though we're remote, I think there's been a really strong push to try to make sure that people are still doing some of those other activities, like the virtual water cooler kind of stuff that would come in. We have activities where, our HR and groups, they send out, pizzas to everybody, or gingerbread houses. And then we have a gingerbread contest, and everyone will assemble it. And But also there's just, like you mentioned, we'll play board games either virtually, we'll try to do it in person, set up small groups here and there. I think the company hierarchy and something is not so like, I think there's a lot of collaboration across different groups, and there's a lot more, yeah, there's conversations and other things is really, I think, promoted, I would say. So that's yeah.
We should set up a games night though in the building there, right? Because
Yes.
like my office is in the 103rd Street building. We should have a games night for like all the tech companies. There's a whole bunch of them in the building.
And there's a
Absolutely.
wonderful space. There's a wonderful space
No,
that
it's
they set up
amazing.
downstairs, and that's
Yeah,
where we play.
fantastic.
So yes, I'm down for that. Sounds great.
All right, we'll work on that. That's what we'll do.
Yes.
Well,
And to answer your other question, oh
Go
yeah,
ahead.
I noticed you were asking about upsampling and or using synthetic data, and that's definitely something we've tried, and have like, I guess it's maybe we haven't really figured out how to make that work the best. There's still some work maybe to explore that area maybe a bit further, but you know, we settled on maybe other various techniques, but it's definitely something we tried at a couple times. So that's so far. Trying to use
But it hasn't
synthetic
worked
data
for
or
you.
making not that great. Yeah.
Like, have you looked at variational autoencoders and you know, and I mean, and this sort of plays into the idea of explainability and, you know, being able to, you know, learn your semantic vectors, and then you can do analysis on the semantic space once you've built an auto. And if you have an autoencoder, then the decoder part is a simulator, right? Which you can then use in actually your analysis, right? And you can use it to smooth data. You could do label. I don't know if you've done anything like with label distribution or feature distribution, if you've looked at any of those techniques.
So I can say that yeah, so it's something we've dabbled in a little bit. I would say that because we end up dealing with a lot of different custom models, and we end up getting like, you know, I can't even think about how many different custom models we end up building, but it's significant. Like you know, we're talking many dozens of models that go through, and for different companies will have different things. So we're always trying to more mission match and try to pull in data to see from different places. And I think that doing that exploration, what we found is oftentimes you might get something that works, but if it's not reproducible across the board, well, now you've just done something that's great for one group, but if you can't, you know, you might have to then do more research to make it available somewhere else or do something else. And that sometimes limits us. We want to move quickly and be able to, you know, churn these out much more fast. So,
I'm afraid. Oh, wow. Calvin has a question. He just made it under the line. It's 12:59.
Yeah.
Calvin, go right ahead. How do you manage the life cycle of all the custom models that you have?
Yes, so that happens. A lot of monitoring tools and certain things have been put in place to capture and to look at. We create baselines based on the data that we had for training, the data that they would have had within that space as well. So sometimes just even a customer baseline, are they strained or not? And we start looking at the variables of every feature. We start looking at the monitoring of performance on all these metrics and how much, trying to know how much of an impact that's having. And those really give us indicators at what point certain things we have to, you know, revisit. At what point is it that we have to jump back in? Now, when you have something like COVID, you know, if you have monitoring, you'll notice that everything would fire, right? During that period, we have situations where the worst borrowers tend to do the best, which totally breaks, you know, flips models around. But it doesn't really matter from the lender's perspective because they're getting paid, right? But it matters if your rank order totally flips on you, like those people who are at the high end start making less money, and the people who were making no money now start making some because the government's funding it, you get this flip. And now all of a sudden things are very different. So going after that, you know, we are seeing things coming back to normal, but there's still evidence and there's still pieces that I think we're seeing trailing effects of COVID still in the market, and it's shaping out. And, you know, again, we're sometimes slow to react in some spaces where it takes over a year to get some targets. So we have to look at, you know, proxy, different ways to look at that. Yeah, there's a lot of research, there's a lot of constant work going on in that space, I guess, for us.
Okay, you know, Matt and Lenora, I think you have succeeded in making the FinTech area and trust science cool. Like that was a hard hill to climb. Justin, any final words before we wrap up? I know we're over time.
Thank you both so much. This is really fascinating. You both did a great job. So thank you so much for the time.
Hey, no problem. Thanks for having us.
Definitely a pleasure. Everyone link in with Trust Science, Technology Alberta, and Niraj, thank you. Any last words to wrap up the session today?
Oh, wonderful presentation. I really enjoyed the talk and the discussion. Thanks, Lenora and Matt, for this wonderful talk. And thanks, Gail and Justin, for bringing such interesting talks to us. Thanks, everyone, for joining in today. We will see you next week. Stay tuned. Thank you so much.
Bye, everyone.
Thanks.